Hello, my name is Tarek, and today our topic of discussion is Josephus problem. So, what Josephus problem is, and how can we solve this problem? It's a simple problem, but an interesting one. Let's discuss this problem now. The Josephus problem is named after Flavius Joseph, a Jewish historian living in the first century. According to Josephus, he and his 40 soldiers were trapped in a cave, the exit of which was blocked by the Romans. They chose to suicide over capture and decided that they would form a circle and start killing themselves using a step of three. Josephus states that by the luck or possibly by the hand of God, he and another man remained the last, and they gave up to the Romans. So now, what the problem is? The problem is very simple. Uh, the problem is very simple. There are few people who are standing in a circular form, and they start to kill themselves until a single person remains. So let's say with the step of three, or you can say with the hop of three. So let's suppose there are 8 persons standing in a circular shape, and let's say the number of hops they will perform is hops, let's equals to 3. So starting with the position 1, and it's a pointer, right? So starting with the position 1, hop 1, hop 2, and then 3, right? From 1 to 2 is 1 hop, 2 to 3 is second, and 3 to 4 is third. So the fourth person commits suicide, so he's out of the circle. Now starting with the position 5, 5 to 6 is 1, 6 to 7 is 2, and 7 to 8 is 3. So he is out. Now starting with the 1, 1 to 2, and 2 to 3, and 3 to 5. He is out. Starting with the 6, 6 to 7, 7 to 1, and 1 to 2. So he is out. Starting with number 3, 3 to 6, 6 to 7, 7 to 1. So the 1 is out. Starting with 3, 3 to 6, 6 to 7, and 7 to 3. So he is out. And now starting with 6, 6 to 7, 7 to 6, and 6 to 7. So the last man that will remain is number 6. The sixth person will be the last one. So the problem is we need to find out the last person standing in the circle. And how can we solve this problem with the help of data structures? So now this is a problem is given to us, and we need to solve this, and we need to find out what will be the last person who will be there. So we have been given a set of numbers, or you can say set of objects, whatever you can call them, and we need to, with the help of this method, we need to find out the last one. So we have arrays data structure to solve this, and we have list data structure. In list we have simple list, like the simple one we use, and we implemented this with the help of arrays. And the second type is linked list. So which data structure to choose in order to solve this problem efficiently? The selection of data structure is very important in solving a problem, because the selection determines that how effectively you can solve the problem, or the bad selection of data structure can make the solution complex. So suppose we are taking arrays as a primary data structure for this problem. So now here's an array, and we have this we have the length of the array is 10. We have 10 different elements, and we are solving the Josephus problem with the use of an array. Okay, the hops we are using is 3. We are using 3 hops. So starting with the position 1, 1 to 2 is 1, 2 to 3, and 3 to 4. So the fourth person will be out. Okay, now what we will do? Should we shift all these remaining elements to the blank to the left hand side, or should we leave this as it is? So this is the first problem. If we are eliminating or we are nullifying any element, then we would have to shift the element. Let's suppose we are not shifting anything, we are just leaving it as it is. So now move to the fifth element. 5 to 6 is 1, 6 to 7, and 7 to 8. Now the 8 is gone. Now we are not shifting the elements. From this point we are moving on. 9 is the first element, 9 to 10. And then at the end of the array we will again shift our control to the first element, 10 to 1 and 1 to 2. Now the 2 is gone. Okay, now what happens? Now we will have to keep track the number of elements that have been deleted, because now we will also we will jump from the element those which are not there, not there. Suppose we are standing at the position 3. Now the number of hops we want to take is 3, so we cannot do 3 to the blank. This is not one hop. The one hop will be 3 to 5. This will be counted as a hop. This will be counted as a jump. So we also need to take care of the null elements if we are not shifting all of them. So with the help of an array, as you can see, the solution is not a simple one. It's becoming complex. Either if we are shifting elements, then we after every deletion we will have to shift the element. And if we are not shifting element, then we will take care of the number of hops. Then how will we make jumps from one element to another in order to count the correct number of hops. So with the array, it doesn't seem to be appropriate that the array is it doesn't seem that the appropriate data structure is array. So let's take help from the linked list data structure. So here's a linked list, and for suppose let's say we don't have previous for right now. Let's just forget this previous marker, this previous pointer. So now what will happen? We are standing at the position 1, then we will move the pointer 1, hop number 1, and then 1 to 2 is number for the first hop, and second hop, and this is third hop. So now the fourth element has gone, and we will start with the fifth one. Now in the case of linked list, we need to manage the list. We need to manage the links. Now the fourth object has been deleted, has gone. So the third element will start pointing towards the fifth one, right? Let me take you to the next slide, and this will be more appropriate for you. Now suppose we are standing, let's forget this pointer. Now we are standing at the data element 1, right? There are 10 people who are standing in the form of circle, and we are standing at 1. So the number of hop is 3, right? So we will take hops equals 3, or we can take 2, 4, any number we want. Just for the sake of simplicity, we are taking 3 as the number of count or number of jumps we will perform. So from this point, 1 to 2 is 1, 2 to 3 is second, 3 to 4 is third. So the fourth element, the fourth person will commit suicide when he is gone. Now we will have to reference this. We will have to make the element 3 point to the element 5, right? We need to make this reference. So we just need to make this reference, and we are good to continue. we don't need to shift any element, don't need to take care of, we need to track the null elements as we did or as we saw in the arrays case. So now starting from the fifth position, 5 to 6 is 1 first hop, 6 to 7 is second hop, and 7 to 8 is third hop. So now the eighth person has committed suicide and he is gone. Now we just need to reference, the 7th was referencing 8 previously, now the 7th element or the 7th node will reference the 9th node, right? And we are good. Now starting with the 9 to 10 is first hop, 10 to 1 is second hop, and 1 to 2 is third hop. He is gone. And we just make this reference point to third one. So in this way we can solve this problem and we can get the last person in the circle. Who will be the last person using this procedure? So as you saw that the selection of data structures, appropriate selection of data structures is very important in order to solve problems. The more knowledge you have about data structures, you will be able to solve complex problems in a smarter way. So in the next lecture we will implement this solution, and I hope this problem will be now clear to you. Thank you for watching.